7.8 Finding min and max values using if statement. So far, mainly we are performing concept-wise programs. Concept-wise programs means studying one concept and working out one or more corresponding programs. By those programs, you can understand the concept. Then you can own the concept practically. Now, that is very essential. It is an essential prerequisite, no doubt about that. But we have to study a little more. We have to take up domains, individual issues, and then we have to solve. Then there is scope of applying logic. Logic is very essential. You should improve logical knowledge, logical analysis. For this, you have to take up now by studying books on logics and all that. You cannot improve logics. For competitive exams and all that, students study that. Actually, in my view, the advantage out of that is very little. If you take up a domain, actually a practical case, and apply your knowledge in the language and get the solution, then you have a wonderful opportunity to study a case and derive a logic. That is very essential because domain to domain, the logic required is different. So every domain you take, every domain is is having unique features. Then you have to focus on that. Then you can find out a logical solution. By that, you have to every time you have to concentrate on new issues and sharpen your logical power. So this program is that type, and you apply your logical power, and at the same time you apply your command over the language. In these programs, more than one concept we apply. Actually, earlier program, concept-wise programs, mainly focusing on a particular concept. It is not that. These programs we apply more than one concept also. So, language-wise, you can achieve command, and you can understand domains, and you can improve your sharpen your logical power because of these applications. Of course, this is a small application. Gradually, at the end of the chapter, you can find beautiful applications. Now, here, what is our task? 3 integer values we are entering, and we are storing them in A, B, and C. A, B, and C. Then int A, B, and C. We have to evaluate minimum value among 3 and maximum value among 3. That is our task. Of course, a very simple task. So, you study the program 7.5. Here, 10th line, you are reading 3 values using scanf. Thereafter, you are writing all the 3 values. And now, here the issue, logical issue, min. We have to find out min and next max. For finding out min, we have taken up very simple logic. Now, if every time interactively you are entering values A, B, C, any value can be min. So, let us assume, start with. What do you mean? We are assuming that A is min. For this, you have to write this statement. Then, according to you, when B is min, now we are assuming A is min. It may not be so. When B is min, if B is greater than A, B is greater than A, then obviously min is B. If B is greater than A, min is B. Don't confuse this statement, you can write here also. And sometimes, for the sake of clarity, we can write here. Nothing wrong in that. Because anything, we should follow conventions for readability. Then, whenever it improves readability, we can write like this also. Now, you see, it improves readability. The side by side, these are there. Now, if B is greater than A, min is B. Next, when C is max, C is greater than B, min is C. This is simple logic we have written. Here, one basic condition, A, B, C must be integer values and those are different values. This logic does not work for equal values. Understand? So, always you give enter different values and this is the logic. Then, in the same manner, max also you can find out. Then assume max is equal to A. That means you are assuming A is max. Then when B is max, when B is greater than A, then max is A, max is B. Then if C is greater than B, max is C. Okay, simple logic like this only we have applied. Now we are writing minimum value and maximum value. A very simple logic, you are able to understand this. Now you see, according to this, first run, which values we are given? We have given A 1, 3, 5. We have given A 1, 3, 5. Now let us evaluate whether the logic is working properly or not. Now we assumed that A is minimum. That means 1 is minimum. 1 is minimum. Next, B is greater than, here we are talking about minimum, so you must B is less than A, min is B, C is less than B. I made a mistake, just to correct it. B is less than A, min is B. Then B is less than A, 3 is less than A, that is false. So this is simply ignored. Second one, second one, C is less than B. What is C? 5. 5 is less than B. That is also not, that is false. That's why, what is the final value? What is stored in minimum? 1. So 1 is minimum. You see that this is true. 135. Out of 135, 1 is minimum. That is the correct answer. Thereafter, come to max. We assumed A is max. Okay, we assumed that. Then, if B is greater than A, B is greater than A. Now you see, B is 3 and A is 1. This is true. Then what is max? 3 is max. Then you see, if C is greater than B, then this is also true. Then present max is 5. So now 1 is min and 5 is max. That is true also. These are simple values, you can know that. That's why you feel that this logic is working well. Okay, let us, now we have given all positive values. If you want to give even negative value, zeros also you can give. Let us try that also. Because in second run, because all types of, whenever you write a program and if it is working, you cannot take it as granted. Your responsibility is siege. Now, what type of values you have given? All positive values you have given. We can give positive values, negative values, as well as 0 also we can give. Now, let us give a different value. 1 negative value, -2, and 1 0, and 3. Then, if the program, this logic works fine for this, then it's okay. Now let us test that also. Now what we assume, -2 is minimum. This is A, B, C. Second run you study. Now -2 is min. Next, if B is less than A, B is not less than A, so it is simply ignored. And C is less than B. C is less than B. That is also false. That's why minus 2 is min. Okay. Now let's come to max. Now what we assume? Minus 2 is max. Minus 2 is max. Then if B is greater than A, B is greater than A, 0 is greater than minus 2, then what is max? Max is 0. Max is 0. And next one, you see, C is greater than B, and C is 3, 3 is greater than 0, then max is 3. You see that in the three values, minus 2, 0 and plus 3. Now minus 2 is minimum and plus 3 is maximum. Plus 3 is maximum. This run also, this logic works fine, and we have got the correct result. And next, one more set of values we give, and test. And already explained to you in the 6th chapter. Simply trying one or two sets of input, you cannot take it as granted, your job is over. All probable types of inputs, that what probable types now, this is one type, this is another type of input, and I am giving one more type of input. Now let's give one more set of input values, same values, but we are changing order. Just try to understand this concept. Now probable input values, whatever values you can give, all sets of values, all types of sets of values you should give and test it. Then only you can confirm, yes sir, whether this program is evaluating properly or not. Accuracy is more important. Now here let us try now. A is minus 2, B is 3 and C is 0. How it works, let us see. Let us assume that minus 2, A is minimum. Okay, it's fine. Next, B is less than A. That is, B is less than, B is 3. 3 is less than minus 2. That is wrong. So, this is simply ignored. Next, C is less than B. This is true. This is true. That's why, what is the minimum now? 0 is minimum. 0 is minimum. Now, let us come to max. Now, here, max, assume max, minus 2 is max. If B is greater than A, B is obviously greater than A, 3 is greater than minus 2, then what is the result? B is max. B is max. Next, C is greater than, C is greater than 0 is greater than 3. Then this is wrong. This is wrong. This is ignored. That's why what is max? Max is 3. Now you see the anomaly. Max is 3. That is true. Minus 2, 3, 0. And as far as min is 0. Min is 0. Min is 0 is wrong. That what is minimum? Minus 2. Minus 2. Now you see what are the logical errors by this program, you can understand. Actually, by my description, you may not grasp all the elements. Some elements practically you have to see. And now you see 2 runs work fine. Suppose you developed this program with this logic, and you have given 2 sets of values, and both are working well. Then simply, if you take it as granted, your program is accurately working, then it is wrong. There is a bug in that. Now, for this set of values, it is not working properly. So, all probable sets of values, you have to give to the program and manually test. Then only you have to take it as granted, your program is working fine. Now, you wonder, everything is all right, why your program is not working properly? Why program is not working properly for some sets of input. For some sets of input, it is working fine. But other sets of why, third set of input, why it does not work well? Actually, your logic is not complete. It is incomplete logic. It is not foolproof logic. Foolproof logic, why it is not foolproof logic? Just I tell you the simple reason, and I have given a complete program in the next concept. And here you see, now you are just assuming A as minimum, nothing wrong in that. When you can conclusively tell, B is minimum, B should be compared with A and C, then only you can conclude that. That is the flaw in that. When you can conclude C is minimum, C should be compared with A and B, then only you get the correct answer. In the case of max also, the same case. So, in this manner, you have to write foolproof logic. This is not complete logic. Complete logic, wherever the complete logic is not defined, system behaves wild. Your program works as it's like, then it gives wrong result. These are logical errors. Logical errors only in program testing can know. Compiler has no responsibility to find out your logical flaws or incompleteness. Understand that point? That's why practically with the incomplete logic I have given, I have written the program, and being a beginner, you feel that this logic is fine, but it's not a complete logic. Now you see, you have to decide one person who is greater in marks or anything. Then how you decide? You compare each person with the remaining two. There are A, B, C persons. You have to decide who is greater. Who is greater means what you do? Every person is compared with the remaining two and come to the judgment. You should not compare with the only one person. This is the flaw here, and let us write the foolproof logic.